welcome to this episode of Night Sky News for May 2021 with me, astrophysicist Dr. Becky Smethurst. This is a show where we chat about what you can look out for in the night sky in the coming month, and we chat about what's been happening in space news in the past month. Any scientific paper I mention will be linked in the description below, and you can use the chapter titles to skip ahead to any story that you're interested in. Or you can stick with me and start here by looking up. First up, we've got a lunar eclipse on the 26th and the 27th of May for the sort of Western Americas, Eastern Asia, and Oceania. And this is going to coincide with the supermoon as well, which is when the moon is slightly closer to us in its orbit. Its orbit isn't a perfect circle, so sometimes it's closer and sometimes it's further away. So you might hear this described in the media in the next sort of coming weeks as a super blood moon, a blood moon being a very colloquial term for a lunar eclipse because the moon sort of looks red when it happens, or even a super blood flower moon. Now, flower isn't an astronomical term. It's from the Farmer's Almanac, and it's what all full moons in May are called. And for some reason, the world's media has just jumped on this and ran with it, causing me endless headaches and having to explain why the full moon in April didn't look pink. But anyway, a lunar eclipse, or a blood moon, is when the full moon passes into Earth's shadow. So the Earth will be between the sun and the moon. Now, because Earth has an atmosphere, which, yay for us, oxygen to breathe, it doesn't actually have crisp edges, its shadow. It's actually a little bit fuzzy around the edges, which means that the shadow of Earth actually has two parts, the penumbra and the umbra. And it's only in the very centre of that umbra does the moon actually go dark. In the rest of the umbra and the penumbra, we've got light refracting through the Earth's atmosphere, essentially giving us like a sunset shadow, which causes this sort of beautiful orange glow on the moon. This map shows where the eclipse is actually visible. If you're in Eastern Australia or New Zealand, around the Pacific, you can see the whole eclipse on the night of the 26th from 6 p.m. to 11 p.m. If you're further west in Australia, or if you're in Eastern Asia, you'll see the eclipse as the moon is rising on the night of the 26th. Whereas on the coast of the Americas, you'll see the eclipse early morning on the 26th, just before the moon sets. I'll put a link in the description below to that website I was just using so that for wherever you are in the world, you can put in your location and you can find out the times for the eclipse of when it will start, when its maximum will be, and when it will finish as well, so you can make sure you don't miss it. All right, something for everybody now, wherever you are in the world. On the 28th of May, Mercury and Venus are going to come really close together on the sky, from Earth's perspective anyway, as we see them. And it's the closest they'll get until 2033. Now, to see this, you're going to need quite a clear view of the horizon towards the west. So if you can usually see the sunset, like physically dropping below the horizon itself without, a tree or a building or a hill in the way, or if you know a place that you could drive to somewhere where you'll be able to see that, that's what you need to do, because Mercury and Venus are going to be very low down on the sky and they're going to be blocked by other things if you don't have that clear view of the horizon. Now, they're going to come within 0.4 degrees of each other on the sky. So that's actually smaller than if you hold out your thumb at arm's length and you can sort of block out the full moon. That's about 0.5 degree. So just a little bit closer together than how your thumb appears when you hold it out in front of you. Now, you'll probably spot Venus very easily. It's the brightest thing in the sky at the minute after, the moon and the sun. So it should be the only thing that you can see in that fairly bright sky after sunset. Now, Mercury, despite being right next to it, will also be a few hundred times fainter than Venus right now. So you'll probably need binoculars to pick Mercury out, or a telescope if you've got one, break that out as well. If you don't worry, just enjoy the beautiful view of Venus at the minute, because it really is spectacular. As it gets darker, you might have a better chance of picking out Mercury, but of course you've got to balance that with the fact that Venus and Mercury are also setting as well as the sky gets darker. If you miss that though, look out for the moon sweeping past Jupiter and Saturn at the very end of May on the bank holiday weekend here in the UK. Again, this is visible wherever you are in the world, but this one will be very early morning, before dawn rather than after sunset. So if you're perhaps an early riser, you should definitely look out for this one, or perhaps, you just can't make it through the night without getting up to go to the loo anymore. Just on your way back from the loo, just crack those curtains and have a look and see if you can spot the full moon in the south. So, the room in your house that probably is the brightest, that gets the most light throughout the day, look through that window, because and you hopefully should be able to spot the moon. And then once you have, you can look out for Jupiter and Saturn. So on May 31st, it's closest to Saturn, and on June 1st, it's between Jupiter and Saturn, and by the morning of June the 2nd, it's closest to Jupiter. So it should be fairly easy to pick out Jupiter and Saturn as a pair. Jupiter will be the much brighter of the two because it is so much bigger. So you'll probably be able to pick that out much more easily against the background stars. Saturn will be slightly yellower than everything else in the sky. So that's how you should be able to pick it out. If you can't, don't worry, try one of those star apps that allows you to point at something and it tells you what you're seeing, and then you can be sure if that's what you actually spotted. Saturn's ring phase is beautiful right now as well. We can see so much of them, which we can't always because Saturn turns on its axis with a tilt. So as it rotates around the sun, our view of it actually changes. If you want to be able to spot Saturn's rings, you're going to need a telescope with at least about 50 times magnification. So if you've got one, I don't know, knocking around the house, who has a telescope with 50 times magnification knocking around the house? Maybe some people. Break it out. And if you fancy some very early morning observations, see if you can spot Saturn's rings. Then on the 10th of June, we have another eclipse, this time an annular eclipse of the sun by the moon. So not a total eclipse, the moon is actually too far away, and remember, it's not quite circular orbit to block out the sun completely. So instead you get this ring of the sun still visible around the outside like a little halo. Now, unfortunately, not everyone is going to get to see that annular eclipse. There's only a few lucky people in the world. So if you are in the Ontario, Canada region right now, I am very jealous of you because essentially you're going to be on that path of maximum eclipse, which you can see starts with the sunrise over northern Canada, goes across the Arctic, and then into far eastern Russia for the sunset. Now, if you're anywhere from sort of the northwest states in Canada to northern Europe and Russia, sort of shaded in on this map, then you'll just be able to see like a bite taken out of the sun as the moon just skims it from your perspective. Please remember though, do not look directly at the sun. It's idiotic. You will completely and utterly damage your eyes if you do that. If you have special sun viewing glasses for eclipses, perhaps especially if you are in North America and perhaps you watched the greatest eclipse back in 2017 that you guys had, you might still have some eclipse glasses knocking around somewhere that you can break out to view this. If not, don't worry. My favorite way to view eclipses is actually to project them through something. So for example, a colander or a vegetable strainer, something that has lots of holes in it, if you hold that up and project the sunlight down through it onto, say, like a white piece of paper or even onto the ground, you'll be able to see where the sun's passed through those holes, actually the little chunk that the moon has taken out of the sun. It's really, really fun to do. A fun, like, you know, if you're still at home, maybe still homeschooling the kids or you're still working from home or something, set that up and then set up a little time lapse so you can see the moon sort of moving across it and taking that chunk out of the sun. That would be awesome to do. Again, I'll pop a link in the description below so that you can see how much of the sun is actually going to be blocked from where you are in the world and what time that's going to start and stop at as well. So if you want to watch this on the 10th of June, you can. Then finally, we couldn't wrap up our night sky news without mention of a toenail moon now, could we? This one on the 11th of June, pairing up with Venus and Mars in the west just after sunset. Again, this is visible anywhere in the world. On the 11th, the moon will be closest to Venus. On the 12th, it will be in between them. And then on the 13th, it will be closest to Mars. This is going to be a great one to try and snap pictures of because first of all, you've got 3 nights that you can pray for clear skies to try and capture this with the moon pairing up with either Venus or Mars. And this actually happened in May, about a week ago as well. But Mercury was still around then. And I had so many of you send me pictures on social media from all over the world. I can't show them all, but thank you to everyone who sent me a picture, whether from a smartphone or a fancy camera. I loved every single one of those toenail moons. All right, that's enough of looking up. Let's come back down to Earth and chat about what's been happening in space news this month. Everything has been happening in space news this month. There's just so much for us to talk about. We sadly lost astronaut Michael Collins, the command module pilot of the Apollo 11 mission. He stayed aboard the sort of main craft as Neil and Buzz went down to land on the moon in the little skiff that will light a lunar module. Now, he's often the forgotten member of the Apollo 11 crew, so I like to remind people of him all the time. I think his legacy will really live on in the science research made possible by the Apollo missions, but also his public service and his science communication efforts as well. We had a lot of other news in terms of space exploration as well. SpaceX finally managed to land their Starship rocket without blowing it up, whereas the Chinese Space Agency just let one of their rockets just fall from space without a care for where or when it would land. Luckily, it did land in the sea just off the coast of the Maldives. Nobody was hurt and no human settlements were impacted at all, but really the international community have rallied now to be like, hi, we need some space lawyers to set down some requirements for this is what rockets need if you're going to launch them into space. That is definitely more like rocket science though, and not astrophysics. The two are very different. If you do want more rocket science, you should check out Tim Dodd's channel, Everyday Astronaut, or you can follow Jonathan McDowell on Twitter, one of my astrophysics colleagues who's really into this stuff. But here we're going to focus more on the science side of things, the actual astrophysics, and to be honest, I think we're just going to have to spend quite a lot of time on Mars on this episode. So let's first start with Ingenuity, the little helicopter that could, right? After its first sort of up and down short flight over a month ago, which proved that flight in the Martian atmosphere was even possible, it's been demonstrating it can, spin, give us a little twirl, and then it can fly horizontally, and it's also been about 10 meters off the ground now as well, so it's just exceeded all expectations. Plus, Perseverance even recorded the sound of Ingenuity's rotor blades just whirring away against the backdrop of the Martian wind. Check this out. That was the first time a spacecraft on another planet has recorded the sound of another spacecraft in flight on another planet. So it's a pretty cool first, and I don't get tired of listening to it, especially like you've got the Martian wind as well, making it sound so familiar and yet alien at the same time. It's fantastic. Now, the original plan with Ingenuity was that it would show off that it could do all of these things, fingers crossed, which it now has done, over the space of about 30 days, and then that would be mission over. And that was because we need Perseverance to communicate with Ingenuity. So we send the commands for what Ingenuity should do in flight to Perseverance, and then it relays them to Ingenuity. Perseverance, after those 30 days were up, was planning to now start its science mission, where it would start to actually rove across the red planet's surface, as rovers are obviously designed to do. That meant leaving Ingenuity behind because it wasn't really known if Ingenuity would actually be able to keep up with Perseverance or not to be able to relay those commands. We didn't want this untested technology to slow down the science mission of Perseverance in any way as it roved around the surface looking for signs of life, either microbial or fossils or something like that. But because Ingenuity has just exceeded everyone's expectations in terms of what we thought it would be capable of, and because it's performing so well, its mission has been extended by NASA by 30 days. So it's going to tag along with Perseverance as it starts to rove, because Perseverance isn't going very far in these first 30 days. It will be in the next couple of months it starts to rove much further. And again, then we don't know if Ingenuity will be able to keep up. But what Ingenuity is going to do essentially is try and scope ahead for Perseverance. Look for areas that would be interesting to look at, but also look out for hazards in the terrain as Perseverance picks out a route as well to various different locations and places it could go. So I guess they're trying to get as much out of Ingenuity as they possibly can, sort of seeing what's possible and seeing how they can help the Perseverance science mission rather than be a hindrance to it. So the next 30 days will be an even bigger test of Ingenuity, right? Because this ground that it's going to cover or fly over is completely unsurveyed terrain. This wasn't expected that it would fly over this region. So it could be that it has a really bad landing on some uneven terrain and it, just comes a cropper and we lose Ingenuity, fine. But now this is all sort of like bonus and seeing how it can help Perseverance in its science mission. So that is really exciting to think of, and I'm really glad they've extended the mission, mainly because I just love the idea of little Ginny and little Percy sticking together on the surface of Mars. Now, Perseverance hasn't been idle while Ingenuity's just been buzzing around it. In fact, it actually cranked up one of its science instruments on board called MOXIE. And this little box, probably about the size of a toaster, has managed to take carbon dioxide from the Martian atmosphere and convert it into oxygen. On the 20th of April, it managed to make over 5 grams of oxygen in about the space of an hour. Now it does this by heating and compressing carbon dioxide that it pulls out of the Martian atmosphere to about 800 degrees Celsius, and then uses an electric current as a catalyst to spur the chemical reaction to split those bonds holding together that carbon dioxide, and you manage to make carbon monoxide and oxygen in that process. Carbon monoxide is then pumped back out into the Martian atmosphere, and then you can keep the oxygen to do whatever you want to do with it. And this is such a big deal, because if, we are serious about goals of putting humans onto Mars or making some sort of base on Mars, you're obviously going to need oxygen. Now, you're not just going to need oxygen in terms of astronauts need oxygen to breathe, but also liquid oxygen is extremely flammable and it's used as rocket fuel. Now, 4 astronauts or so, say on the surface of Mars for a year, would probably breathe and need about a ton of oxygen. Whereas the rocket to get them back off the surface to Earth would probably need about 25 tons of oxygen. So you need to make a lot more oxygen for rocket fuel than you do necessarily for them to breathe it. But getting 26 tons of oxygen all the way to Mars, you don't want to ship that. You don't want to have to make your craft that you're launching from Earth any heavier, meaning you need more rocket fuel to do that as well. You actually want to make it maybe out of raw materials that you've got access to on Mars itself. So despite the fact that MOXIE is the size of a toaster with the same amount of power as a car battery, and even though it only produced about 5 grams of oxygen, right, it still proved that this is actually possible to do. And yeah, okay, the oxygen that's made probably won't be kept for any kind of future missions. Perseverance just doesn't really have the luggage room to store it, right? It does prove that it's possible, and it does mean that we can start planning to maybe scale this up further for future missions that we might want to take humans to Mars in however many decades time that might be, that we're talking about here in terms of a permanent base. But it's really exciting to know that, that dream of sort of making oxygen out of the raw materials on Mars is actually possible. Other more random things to come off the back of the Perseverance mission was this claim that these images showed mushrooms on Mars. Now, it's worth pointing out here that yes, Perseverance mission is to try and find signs of life on Mars. The original thought was that would probably be microbial life if it was living, but most likely probably fossilized microbial life that used to exist in the past on Mars. Now, all the images that Perseverance takes, NASA makes public, so it's not just the NASA science team that can analyze these. It's basically anyone in the world that can get their hands on them can have a crack at analyzing these images and doing some science. This study that was published this month, though, claiming that these photos were mushrooms, was, how can I put this nicely? It was a bit lacking, let's say. It's in a journal that's infamous for just sort of skipping the peer review process. That's where you get another scientist to read your work and check that you've gone through the scientific method properly and that what they're actually publishing is good science. So they're not really very good at checking the quality of the papers they publish and if the claims actually have legs to stand on. So the claims they're making is that in these images, these spherical objects seem to have changed size over the course of a few days. And they pointed out that they look a little bit like puffball mushrooms on Earth, which are also known for very rapid growth rate over a few days. Now, pointing out that something kind of looks like something I've seen before is not scientific evidence, right? They have nothing to back up these claims that they could be mushrooms. A much simpler explanation would just be that the Martian wind has blown around some of those sand grains around the image, burying and then revealing these spherical things that, to be honest, are probably just pebbles. So while these images are definitely very interesting and people will definitely be looking at them a lot further, the leap to these are mushrooms is not scientifically motivated at all. So while Perseverance's eventual goal is, yes, okay, to find signs of life, and who knows, maybe that might end up being some form of fossilized fungi, it's not going to come from someone pointing at an image and going, hey, that looks like a mushroom that I've seen on Earth, right? It's going to come from a lot more robust evidence than that. And I think this quote by Paul Myers, who's a developmental biologist at the University of Minnesota, kind of summed it up the best. Claiming that mushrooms are sprouting all over Mars is an extraordinary claim that requires better evidence than an analysis of photographic morphology by a known crank who has claimed on the basis of the same kind of analysis that he has seen fields of skulls on Mars. Ouch. So while we're pretty sure we haven't found any evidence for mushrooms on Mars yet, there was a paper published this month that has found evidence for volcanic activity on Mars. Why this is exciting is because it's current volcanic activity. And we know there's been a lot of past volcanic activity on Mars because we see that in the surface features that are left over. For example, Olympus Mons is a volcano with a very similar shape, sort of a formation history to Mauna Kea in Hawaii, and it has evidence of past lava flows all over it. But we've never found anything that suggests that Mars is still volcanically active. We thought that everything might have been a little bit dormant until this study that came out this month by Hovarth and collaborators, who found this deposit of material surrounding this fissure on the surface of Mars, which isn't very reflective, and it contains a very high concentration of something called calcium pyroxene. It essentially identifies it as a pyroclastic deposit of volcanic ash. You might have heard of like pyroclastic flows on Earth, these huge big plumes of very hot volcanic ash that leave behind these deposits. Now, by comparing the material in this deposit to the layers of rock around it, the authors of this study were actually able to estimate how old they thought this deposit was. So if it was made by this volcanic pyroclastic flow, whatever they think it was made by, then how long ago did that actually happen? And they estimated that it would be around about 53,000 years ago to about 210,000 years ago. That's nothing in astronomical timescales, right? That's like yesterday. It's so recent compared to like the 4.5 billion years that we think the solar system and the planets have been around. So the fact that this could be really recent volcanic activity has a lot of big implications for how we understand Mars, but also like huge implications in the search for life on Mars as well. Because if the volcanic activity is recent, then that means that the surface of Mars could be a lot warmer than we thought. And that could help to support life. Like think about sort of like, bacteria that manages to survive in sort of the hot springs in say Iceland or Yellowstone or something like that. It's like thermophilic bacteria that can survive in these very, very warm conditions that are fueled by volcanic activity, essentially. You could have something similar on Mars perhaps, and that might combat the much colder temperatures because it's further away from the sun and has a thinner atmosphere. So this area of Elysium Planitia that they've actually found, this big fissure with this perhaps volcanic deposit around it, could be a very interesting location to send maybe the successor to Perseverance in the hunt for life on Mars. Speaking of future space missions, the James Webb Space Telescope is getting ever closer to its planned launch date of October 2021. Well, it's going to keep getting put back. But because we're getting ever closer now, the final checks are taking place in prep before it gets shipped to the launch site in French Guyana. And that includes the all-important fold-out of its big gold hexagonal mirror, without which it won't be able to collect light and work like a telescope. And if you want to know more about James Webb, my video next week will be all about what the plans are with it, what science we intend to do with it, and I've interviewed someone from the European Space Agency who's been working on it for the past 10 years as well. So look out for that. But now let's talk about black holes, because let's be honest, it's all I ever want to talk about, because I'm just a little black hole enthusiast, all right? And I'm particularly excited about this piece of black hole news because we actually have a brand new candidate for the title of closest black hole to Earth, and it's one of the tiniest black holes we've also ever found as well. This research was done by Jayasinha and collaborators, and they claim to have found a black hole 3 times the mass of the sun orbiting another star just 1,500 light years away in the constellation of Monoceros. It's a constellation next to Orion, which is supposed to look like a unicorn. And given the fact that black holes of this size are incredibly rare, the authors of this study have dubbed this little guy Unicorn. Now, usually the way that we find black holes of this mass, what we call stellar mass black holes, because they're similar in mass to stars, right? 3 times the mass of the sun, rather than like a supermassive black hole, right? It's like 1 billion times the mass of the sun that we find in the centers of galaxies. These stellar mass black holes, usually we find them through the X-ray emission that comes from the regions around them. So usually if they're orbiting another star, they pull off material from that star, which then speeds up as it spirals in towards the black hole. And this region around the black hole starts to glow very brightly in X-rays so that we can detect that and then know the black hole is there. Instead though, in this study, they actually look for stars that were wobbling, essentially like a little sort of gravitational pull or tug by the black hole as the two orbit each other. It's not the black hole that's orbiting the star, the two things are orbiting each other, and so you see the star in the middle wobbling around. This is also the same method that we use to spot some exoplanets as well, so planets orbiting around other stars in our Milky Way. The stars are so bright that you tend to not be able to see the planets that are actually orbiting around them, and that's how you know they're there. Now, the star they observed had a rather large wobble, and that's what allowed them to estimate that the thing that's orbiting around the star and causing this wobble was about 3 times the mass of the sun. Now, if that thing was a star of that size, we would be able to see it incredibly easily at that distance. It would be a very obvious star. But obviously we can't see anything orbiting around this star that's wobbling, so there's the assumption there that it's dark. Now, 3 times the mass of the sun is far too heavy to be a white dwarf or a neutron star. At that point, it would have collapsed down into a black hole. Now, it's possible that instead of being one single black hole that's orbiting that star, it might be a pair of neutron stars or a white dwarf and a neutron star, that the masses add together to give you 3 times the mass of the sun. It's very difficult to prove which scenario you actually have going on here, and the authors haven't been able to do that in this paper, and they state that that could actually be an option. But by the principle of Occam's razor, that the simplest explanation usually turns out to be the right one, the simplest explanation in this case is that it is one single object, and that one single object of 3 times the mass of the sun, which we can't see, must therefore be one single black hole. And at 3 times the mass of the sun, that puts it right smack bang in the middle of something we call the mass gap. Now, in theory, you can have a black hole of any mass you like, right? As long as you can take matter and squish it down. So I could literally take my iPad here, and if I could squish it down dense enough until it would become a black hole of the same mass as this iPad, right? But there's not many processes that we know that can actually take matter and do that to it. I know that my puny little noodle arms wouldn't be able to do that. We do know that it can happen though at the end of a star's life when a star goes supernova, and depending on how heavy that star was originally depends on what you end up getting out at the end. Not that heavy, something like the sun will end up as a white dwarf at the end. It won't even go supernova. But something that's a bit heavier might turn into a neutron star, or if it's even heavier still, then there'll be so much matter there that it won't be able to resist that pull inwards due to gravity, and it'll be compressed down into a black hole. Now, all the black holes that we think are formed in this way that we've found are about 5 times the mass of the sun and up, which leaves a pretty big gap from what we think is the heaviest theoretical limit that a neutron star can get to before collapsing into a black hole of about 2.17 times the mass of the sun. And we don't know if that's actually physical or not, or if it's just an observational bias. Maybe we've only been able to spot those that are 5 times the mass of the sun up because those are the ones that actually start feeding on their star and start glowing in X-rays, which is the way that we've found the majority of these in the past. It might be that loads of black holes exist in this 3 to 4 times the mass of the sun mass gap, like this unicorn black hole that they've dubbed it, that they found in this new way, and we're only just starting to spot them now. As always, more observations needed. We need to see if we can observe more of these stars wobbling because of black holes, see how many we can find. What mass are they? Why aren't they pulling material off their companion star yet and starting to glow in X-rays? So many questions and so much more science to be done. Alright, that's it for Night Sky News for this month. If you want more reactions from me to astronomy news as it happens, then you can follow me over on social media, either on Twitter or Instagram. I also caved and got TikTok as well, where I like to make little short videos about the news that's breaking, stuff like that. Also, send me your pictures of the night sky if you take them as well. I always love to see them. I will be back next week with a video about the James Webb Space Telescope, so keep an eye out for that. But until then, happy stargazing. By comparing this material in the deposit to the layers of rock around it on the Martian surface, the authors of this paper, these Martian geologists, if you will, they're not really geologists, are they? Because geo means earth, so I don't know what the equivalent would be, like malologist. Malologist. Can you imagine introducing yourself like, hi, I'm a malologist? That can't be a word. I'm going to look it up, but that can't be a word. I've got a phone call. Oh, yous are busy though, apparently. Missed phone call while I'm filming, and then they're busy. I think it might be the pub that we're going to this afternoon for my birthday. It's my birthday and I'll talk about black holes if I want to. Now, if the thing that was orbiting around it was a star that big, we would be very easily able to... That's not in the right word. Those words? Were those words in the right word? God. Were those words in the right order? Oh, my brain is fried. All right, that's it for space news. Oh, battery ran out right at the outro. What a little bitch.